Welcome to Master Mathematics in Minutes. Today's topic is about deriving the arithmetic series formula, and we will conclude the topic with a summary. And finally, be kind and subscribe for more videos. So, what is an arithmetic series? The sum of the numbers in an arithmetic progression is called an arithmetic series. So we've defined what an arithmetic progression is in the previous video, with a as the first term, a plus d as the second term, a plus 2d as the third term, and a plus n minus 1d as the final or last term. So we'll add each of these terms together, and that gives us Sn, which is the sum of the n terms, and that is called an arithmetic series. So we've written the sum in ascending order, starting from the first term all the way up to the last term. So in the second equation, we'll rewrite the same sum in descending order, going from the last term to the first term without changing any of the values. So with Sn again, and the last term, which is a plus n minus 1d, now becomes the first term, a plus n minus 1d. And the second last term is a plus n minus 2d, is now the second term, a plus n minus 2d. And the first term, which is a, is now the last term, a. So this sum goes from the last term to the first term. So the next step is to add these two equations together. So adding Sn and Sn, that gives us 2 Sn on the left hand side. And adding the first term on the right hand side, we have a plus a, that gives us 2a. And with plus n minus 1d, that's plus n minus 1d. That's the first term. And we'll add the second terms with a plus a, that is 2a, and with d plus n minus 2 into d, and that gives us n minus 1 into d. And that is the second term. And we'll add the last term with a plus a is 2a, and with n minus 1d and n minus 1d here. So notice that these terms are identical, with 2a plus n minus 1d, first term, 2a plus n minus 1d, that's the second term, and 2a plus n minus 1d as the last term as well. And because the sum is across n terms, we're able to multiply n into 2a plus n minus 1 into d. And we'll copy 2 Sn down on the left hand side. And solving for Sn, that is equals to n over 2 into 2a plus n minus 1 into d. So that is the first formula for the arithmetic series. We can rewrite this formula in a slightly different form. So notice that the last term is called a plus n minus 1 into d, and we'll call that L, which stands for the last term. And the intention is to bring this last term into this formula, which we will derive in the next slide. So we saw earlier that L, which is the last term, is equals to a plus n minus 1 d. So we can substitute this into the formula that we've just derived for Sn. So the first line is identical to what we saw earlier. Sn is equals to n over 2 into 2a plus n minus 1 into d. So we're able to split the 2a out as a plus a, and all of the other terms remain the same. So with a plus n minus 1d, which is that a plus n minus 1d, we can rewrite that as L, and so we could change that to be L, and all of the terms remain unchanged. So with Sn is equals to n over 2 into a plus L. So that is the second formula for the arithmetic series. To summarize, an arithmetic series is the sum of the numbers in an arithmetic progression. So with Sn is equals to a, which is the first term, plus a plus d, which is the second term, plus a plus 2d, which is the third term, going all the way up to last term, which is a plus n minus 1 into d. And we've derived two formulas for the sum Sn. The first one is equals to n over 2 into 2a plus n minus 1 into d. And the second equation is Sn is equals to n over 2 into a plus l being the last term. Thank you very much for watching. This is Master Mathematics in Minutes.